A very good morning to you all, students.
Good morning, sir.
Sorry I missed you yesterday. It was unbearable. I thought I would come in at one point, but I failed totally. And I wish we could arrange an evening or a weekend and we have that lesson covered. You agree and then tell me so that I can see how I can have the lesson covered. So with that, we had introduced what we call the normal approximation to binomial distribution. I had only seen one example and I closed last week. So today allow me to introduce some other examples. And if time allows, we shall introduce confidence interval, which is our last topic. Do you know how it feels to be finishing the syllabus? I guess Mr. DB is also about finalized numerical. Then we shall only be left with some parts of mechanics in paper 2. As per now, all of you can get D1s. At least someone can score 85. Actually, if you're lucky and the mechanics you have taught has been set, you cannot get 100 if you're serious students. So you are ready candidates to sit you name paper 2 right now. So don't say that, Saul suggests 9 to 10 in the evening. Okay, there is an example I've sent them. Number approximation to binomial distribution. There's an example which says it has number 2 on it. A pair of dice. Pair of dice is tossed. It is a short question, even if I write. Is tossed 180 times. And the sum of the outcomes recorded. Find the probability. Find the probability that a sum of 5 occurs. So already some of these topics, I had covered some of them earlier last year with the current senior vacists. So in case some of you want to visit my YouTube, you'll still find there all these videos concerning normal distribution. 1, exactly 28 times. 2, between 20 and 35 inclusive. Now, if I may remind you how to draw the sample space of this kind, where we have a die and another die. Die 1, die 2. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Wow, okay. Let me just increase it a little. Five. 1, 2, 3, 4, 5. Okay. 6. So we have die die 1, die 2. This one has numbers 1, 2, 3, 4, 5, 6. This one has 1, 2, 3, 4, 5, 6. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Those are the two possible outcomes on 1. Then here we shall have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then we have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. I used to have my die around. I don't know where it is. I would have showed you these illustrations. Anyway, those are the possible outcomes. Now they are saying the sum of 5 is to occur. The sum of 5, where is the sum of 5 occurring? 5 occurs if you have 4 plus 1, 1 plus 4, 5 plus 3 plus 2, 2 plus 3. So it is along this line.
Really faint.
You see this? These are the possible outcomes for 5. 1, 2, 3, 4. There are 4 out of a sample space of 36 possibilities. So first of all, you treat that.
What?
If you don't know how to unmute, say, teacher, I don't know how to unmute, so that I can do that very fast. So the probability of getting a sum of 5 is going to be equal to 4 out of 36, which is actually 1 out of 9. Now, because that is what we want, that becomes our P, which is our success, which is 1 out of 9. We can consequently reduce our failure. Our failure rate is 8 out of 9, which is Q. Therefore, because N is 180, we are seeing P is 1 out of 9. We have seen Q. We can get mu. Mu is NP, which is 180 times 1 out of 9. Here once, here 20. The mean is 20. We can get the standard deviation, which is the square root of NPQ, which will give us the root of 8 out of 9 times 180 times 1 out of 9. When you press the calculator, what is the standard deviation?
Excuse me, sir.
Yes, please.
So how did you get 4 out of 36?
Aha. Did you see this table?
Yes, sir.
Now, this table is the sample space for 2 dice tossed at the same time. One dice has numbers 1 up to 6. This is the first dice. The second dice also has numbers 1 to 6. If they are thrown and then picked or released, when you look at them, there is a possibility of having 1, 1. There's a possibility of having 1, 2. There's a possibility of having 5, 3. There's a possibility of having 6, 6, and so on. But the question says, we want the sum of the outcomes that is being recorded to be 5. Find the probability that the sum of 5. Yes, please.
I have not understood you. The sum of 5.
And Kakati, the sum of 5 is this one. I was going there. The sum of 5 is in this sense that the first die, this is die 1, maybe it has 2 on top. Then the second die, to give us a sum of 5, should have what? 3. So when you sum up these 2, you must get what? 5. Does it make sense? Or it can be having 1. This one can be having what? 4. When you sum up the two values on the two dice, you get 5. So the sum of the dice is 5. You know, dice, there are two. Die is 1. Eh? Though in Uganda, they read it as dice when it is 1. I don't know why they ended up reading it like that. So according to this table, let me first finish the first lady. The first lady asked, according to this table, 1, 4 sums up to 5. 2, 3 sums up to 5. 3, 2 sums up to 5. 4, 1 sums up to 5. So how many sums of 5 do we have? 1, 2, 3, 4. Out of how many? All this sample space is 36. Does it make sense? The lady. The lady was asking.
Excuse me, teacher. What can you determine P and Q?
What can you?
I'm meaning that how do you determine for P and Q?
Yeah. This is how you determine P and Q. They have said find the probability that the sum is 5. The sum is 5 is what we want. What we want is our success. Our success is represented by P. I remember when I was talking about binomial distribution, I told you that success does not necessarily mean something good. Success can be whatever the question wants. Even if it is killing people, that is success to some people. We got a bomb blast recently, last week. So people who did the bomb setting, they got their success. If the bomb never went off, they would have got a failure Q. So in this case, success is dependent on what the question wants. What the question predicts is always the success. So we want the outcome of 5, so our success is the probability of getting a 5, which is success P, which we have got as 1 out of 9. Can someone give me the standard deviation? Someone give me a standard deviation.
It is 4.2164.
4.2164.
4.2164. Now the probability of X is equal to what? 28 exactly. If it is exactly 28, it's the same as probability of 28 minus 0.5 minus the mean mu out of sigma is going to be less than Z less than 28 plus 0.5 minus 20 minus the mean mu. Okay, minus mu out of sigma. So when you substitute, we shall have probability of 27.5 minus 20 out of 4.2164 is less than Z is less than what? It's less than 28.5 minus mu out of minus 20 out of 4.2164. What values do we get? So the exact value of 28 lies between 28.5 and 27. The reason is if you get the average of 27.5 and 28.5, the answer must give you 28.
It's
Yeah, what do you get?
1.778.
778.
Yes.
When you round now, it will be 1.779.
Okay. 2.016.
So since
So
your
how
X,
many decimal places do we write?
you write up to 3 because the table reads up to 3. Okay.
So
But if you're using a calculator, you can write up to 4. Then you remember to mention that you've used a what? A calc.
So can you clarify on the symbols? Like when do we write less than or more than or less or equal to?
I'm going to specify, or I'm going to stress more on them. Okay. Like for example, the next question talks about that. So this one has from 0, you're reading from 1.779 up to 2.016. So this is the area we are looking for. So you will get the answer. So I'm going to stress the point of...
Teacher.
Yes, please.
Teacher, is it that every time they give us such numbers, we shall have to subtract 0.5 and add 0.5?
When it is an exact number.
Okay.
For example, they ask you probability of X is 25. 25 lies between 24.5 and what? 25.5, okay? So if you consider that, you've already made it continuous. Yeah? Whereas these other numbers, for example, 20 to 35, you're going to see how we end up subtracting or we end up adding 1.5. The second one has an inequality which is mixed, which is in a way that 20 and 35 are inclusive. But before I go there, who has an answer here? Last time I was using...
I have 0.94048. Calc.
Probability of 1.779 less 2.016. You're saying is
0.94048.
Impossible. It can't be very bigger than 0.5 because already this side is 0.5. It is out. So how does it become 0.9? It is impossible. Someone else. Perhaps you've used the calc and only got for this one. When you use P. Guys, you don't recall how to read tables and calcs. I need you know so much in the remaining parts. I expected you now to be experts. When I mention answer, people just give me. But if you
0.0157.
correct. 0.015.
7 calc.
7 calc. Thank you. Correct. Okay, let's go for the second part. The second part says between 20 and 35 inclusive. It means it is probability of 20 less or equal to X less or equal to 35. My friend, the lady who was asking, if it was like this, probability of X, for example, is greater than 20. I said for continuity, you must first make sure that this is actually probability of X greater or equal to 21. When you introduce the equal sign, then for continuity, because you've seen that, because in this first case, the 20 is not inclusive. The probability we are finding, 20 is not there. Whereas in this second case, the probability of 20, X is greater or equal to 21. 21 is inclusive, but we have missed out some values which are between 20 and 21. So we end up subtracting when standardizing. This is when we subtract for a greater than sign. Whereas if you go for a less than sign, probability of X is less than 20. Then this should be starting from probability of X is less or equal to 19. Here 20 is not inclusive. Here 19 is inclusive. But we have left out some values which are between 19 and 20. So for continuity, you add 0.5. That is why When it is less than or equal to, we subtract 0.5. When it is greater than or equal to, we add 0.5. I mean, when it's greater or equal to, we subtract 0.5. When it's less than or equal to, we add 0.5. Now, let us interpret this number. With that review, probability of 20 is less or equal to x, less or equal to 35. These ones are already inclusive, okay? But check this out. X, first of all, is greater than or equal to 20. And I've told you if it's greater than or equal to, we subtract. Yeah? This is probability of x is greater than or equal to 20. And it is mixed. And the probability of x is less than or equal to 35. And I've said where we have greater than or equal to, we subtract off 0.5. Where we have less than or equal to, we add on 0.5 to standardize. So with this, we shall have probability of 20 minus 0.5 minus 20, the mean, out of the sigma, which is 4 point what? Was 4 point what? 4.2164. 4.2164 is less than Z less than 35 plus 0.5 minus 20 divided by 4.2164. With this reason, can we get the result down here?
We have negative 0.1186.
Negative 0.1186.
6.
Less than Z, less than
3.6761.
676. So because of 3 decimal places, we shall have negative 0.119 is less than Z, less than 3.676. So can we read that from the table for the calc? Then our Bell jar graph will look like this. This is the 0. This side we have negative 0.119. This way we shall have 3.676. So we are having that total area. And what is the answer?
I've gotten 0.54724.
Okay. Any questions?
.54724, Carl.
54724, Carl, okay. Any difference with those of the table? Teacher, how did you get it on a calc? To Gume Jasper. Jasper, do you have a smart calc? Jasper? Yes? Jasper? Jasper, you better talk to me because I can't guide you. Let me hope you're not the one texting. I can't guide you with a text symbol. You talk to me, unmute and speak. Jasper, are you there?
Excuse me, sir.
Yes, please.
Sir, he has a problem with his audio.
Yeah. Kakali, okay, let us try. I don't know whether I will. Now I will not know. That means he already has to type yes, yes. Okay, Jasper. Press mode on your calc. When you see SD, press 1. Okay, press where SD is, that value. Confirm whether you have reached where SD is and you've pressed the value for SD. Have you reached there? Hey, shift 3. Has it brought P2R? If it has brought P2R, the first method, let us start with the Q. Q reads as the table reads. The table reads from 0 up to where you are. So put in, for example, select Q, which is 2, then put in 3.67. After, repeat the same procedure and substitute in negative 0.119. Then you add the two answers. You must be getting the same answer.
Excuse me, sir.
Yes, please.
So here, when you are standardizing, how comes the symbol didn't stay as less or equal to? Why is it only less?
Why is it only less? It's because when you have standardized, Z is always either less or greater than, not having an equal sign. You can't standardize Z and then you have it with equal signs. When it is standardized, it has no equal signs.
Okay, sir, thank you.
Yes, mister, have you got the answers? Is it the same answer? And Kakati now, another option. Go back and pick P. P reads from negative infinity up to where you are. Then substitute both answers. When you subtract, you get the same answer. Then after that, to Gume, you'll investigate R. R reads from where you are up to positive infinity. So that's how you'll investigate them. I hope the rest you can handle.
Yes, sir.
Yeah, okay. Now, guys, let us look at this example. In a refugee camp containing 120 people, exactly 30 are orphans. Where is Ukasha? Ukasha? Ukasha, are you there?
Yes, sir, I'm there.
Read for me the question. Ukasha, read the question. Ukasha, you said you were there. Ukasha, you also. A refugee camp containing 120 people, exactly that are orphans. A group of 48 people is picked at random from the camp. Calculate the probability that between 10 and 16 people inclusive are orphans. Ukasha, what is our success? Ukasha.
Please, sir, I'm not saying that question for the refugee. I'm having the experiment.
The question is on the screen. I've put it on. You're not seeing my screen.
Hey, okay.
Gosh, are you mad? Okay, you answer me. What is the success? What do we want? Gosh, now we're making the lesson get bored. Okay, guys, who knows our success?
People who are orphans.
Our success is to look for orphans, okay? So, what is the probability of getting orphans? Probability of being an orphan is, out of the 120 people, 30 people were orphans. So, the probability of being an orphan is a quarter, and this is our success. Then if you do not get an orphan, you get a what? A person who has parents, which is failure, which is Q, which is 1 minus P, which is 1 minus a quarter, and failure is 3/4. They have said they have selected how many people? 48 people. Out of 48, we are finding the probability. We can get mean, mu, as NP, which is going to be 48 times a quarter. And the answer is 12. Then standard deviation is the square root of NPQ, which is going to be the square root of a quarter times 3/4, which is √3/2. Therefore, the probability of 10 less or equal to x less or equal to 16 is going to be what? It's going to be, because this 10 is less than or equal to x, by standardizing, we shall subtract it off, and we shall have probability of 10 minus 0.5 minus 12 divided by sigma, which is √3/2, is less than z less than 16 plus 0.5 minus 12 divided by √3/2. Calculator, confirm that probability.
Teacher.
Someone saying, teacher? Yes, please.
Shall we multiply by n on deviation?
What?
Shall we multiply by n? Square root of NPQ.
Hey. Oh, okay. And now, by now, this standard deviation in binomial, it's the same as saying it is mu. Tushima, have you seen that?
Yes, sir.
It is the same. So you have to be steady. You never know. They might bring the question in terms of that.
Excuse me, sir.
Yes, please.
So how comes for P we didn't take only 30? Why did we take 30 divided by 120?
It is because you take a look at an example, your class. If your class has 120 people and they tell you only 30 people offer biology, then the probability of biology is actually what? 30 out of the 100. Not so. Now, if they say 50 students have been picked at random from the class, calculate the probability that between 20 and 28 students, inclusive, they offer biology. Does that relate to this understanding?
Excuse me, teacher.
Yes, please.
Why didn't you multiply when you were getting this?
Why did I what?
The standard
why
deviation
did you
is
get
3.
√3? Why did you get √3?
Oh my God. Wait.
You did not put 48. Like you did
My
not
God,
put
I'm sorry, guys. This is supposed to be √3/4. Thank you, nice eyes. Wow. I thought it was because it comes to √3/4 times 4, which is √16. Eh?
Teacher, but then the n.
Teacher, the n.
Okay, I'm sorry. Okay, I'm sorry. I think people have missed the n. The n is here. NPQ, not so. NPQ. NP is the mean. So I multiplied the mean, which I got as a quarter at.
The mean is 12.
As 12.
12.
Guys, did I wake up from the wrong side today? I'm so sorry. Let me make that adjustment. Okay. My bad. According to those questions that have come, let us go traditional. Mean is what? Standard deviation normally is root of what? NP. So we shall have our N is 48. Our P is what?
1 out of 4.
The other is 3 out of 4. Let us minimize having students getting confused. 16 divided by 48, you get 3. The answer is 3. Thank you. So probability of 10 minus 0.5 minus 12 out of 3 is less than Z less than 16 plus 0.5 minus 12.
The answer 3 or 9.
And it is root of 9. Yeah?
Yeah, and thank you. Yeah, I get.
Okay. Someone give me the answers here. I was wondering why people are over asking questions. I was the one in wrong. Sorry, guys. I think I must have looked. I don't know.
Negative 0.833.
Less than Z, less than. That is 14.5, which is 4.5, which is 1.5. Yep.
9.5.
Yes, 1.5.
No, it's 1.5, not 9.5.
Yes, 1.5.
Yeah. So, my friend, who is that one who was getting to use a calculator, to Gube Jasper, can you please get me these answers using P on your calc? First, get me for 1.5. To Gume, press P on your calc, get me the answer using P for 1.5. Then after, get me for negative 0.833. Then those of us who are reading the table and the Q, definitely we shall add. Those of us who are using P and R, we shall subtract the big one minus the smaller one. You get 0.73077. Another one.
The same.
That is the final answer.
Yes, sir.
Yes.
Okay. Kale, people screenshot that. We go for those numbers I sent in the WhatsApp group. Okay. Here is another question. So this question we have a machine. A machine manufacturing nails makes approximately 15%. Manufacturing nails makes approximately 15% that are outside the tolerance limit. If a random sample of 200 nails is taken, find the probability that more than 21 nails will be outside the tolerance limit. So here, it's a binomial approximation to binomial. Reason being, we are seeing that we have two conditions. You either tolerate the nails or you don't tolerate the nails. So, firstly, we have n is equal to 200. Then, to tolerate is to want. So, the other ones are outside the tolerance limit. Outside the tolerance limit is we don't tolerate them, so we don't want them. So what we don't want is a failure, which is 15% out of 100, which is 0.15. What we want is going to be 0.85. So that is how tricky these questions can be. And then the other thing is we can now find the mean, mu, which is NP, which is 0.85 times 200. The answer is the same as 85 times 2, which is 170. You can confirm with the calc. So with that, the question says more than 21 nails. So probability of X is greater than 21. If probability of X is greater than 21, yeah, then there are two options in standardizing. You either say this is probability of X is greater or equal to 22. When it's greater than you, subtract when standardizing by saying probability of Z is greater than 22 minus 0.5 minus the mean, which is, wait a minute. What was the mean? This looks to be very big. Hey, did I get the standard deviation? Standard deviation is root of variance, which is going to be NPQ, which is going to be the square root of 0.85 times 0.15 times N, which is 200. What answer do you get for the standard deviation?
You get 5.0498.
You get
5.0498.
5.0418.
98.
Now this mean is so big compared to the 20s. I think I've interpreted something wrong here. A manufacturer makes approximately 15% that are outside the You know, I've always been explaining that success may not necessarily mean something good. And failure may not necessarily mean something bad. So what we want here, we want to get what is outside the tolerance limits. So tolerance limits, our failure is going to be Q. Our success is going to be this P. So this is what we want outside the tolerance limit. So if that is the case, then this value is going to change. So we shall have 0.15 times 200. And the answer is 30. So 22 minus 0.5 minus 30 divided by 5.0498. When you press the calculator, what answer do we get? Otherwise, the other one was going to be very impossible. It was going to be beyond. Beyond what? Beyond 3. So the other option
Still 5 point, yeah. The same standard deviation.
When you, what do you get when you get this answer?
Negative 1.683.
That's what I wanted. My friend Jasper Tugume. Are you there with your calc? We want beyond negative 1.683. Use R on your calc and give me the answer. Tugume Jasper.
Excuse me, sir. So can't we find the continuity correction when it's only x is more than 21 and I just say it's plus 0.5?
It is okay. It is very okay. It is very, very okay. Actually, I was to comment about it. It's just that my worry is sometimes when you overgive all of them, overuse them, people get confused. So it's better to get one side. So which side do people want? We want to say when it's greater than we add, or we want to say when it's greater or equal to we subtract. I think that one will depend on the learner. You agree to yourself and accept one definition. But my job was to give you all. Okay? So it is the same if you say you add on 0.5 so that you make the continuity be between 21 and 22. Tugume Jasper. You're the person supposed to give us the answer. Is he online? Let me check. Elizabeth Magala, are you there? Give me the answer, please. Elizabeth? We are people.
0.9538.
0.9538. Correct. The second case, between 20 and 30 inclusive will lie outside the tolerance limits. You see what the question is talking about? Lying outside the tolerance limits. So being outside the tolerance limits was actually our success. I'd interpreted it in a funny way. Inclusive. So we have probability of 20 less or equal to x less or equal to 30. This is going to be equal to probability of 20 minus 0.5 minus 30 divided by 5.0498 is less than z less than 30 plus 0.5 minus 30 divided by 5.0498. Can you get me those limits?
Have negative 2.0792. Negative 2.0793. 3, yes.
Less than z.
Zero 0.0990.
So when you see where that probability lies, to lie from the left to the right, inclusive. So get the probability, read the values and get the answer. Can I hear your answers?
0.52064. 52064, Carl. Yes.
Hope to may have the same. Oh, there's this other one I had not showed you. Okay, take that screenshot. I'll give you this other brief one. One time you set it and it was really interesting. Very cheap, very precise, direct to the answer. Have people taken the screenshot? I want to go to the other white page. That's where I want to write the question.
Yes.
Okay. Now, they can give you a number like this. Very interesting, very precise. They say, given that X is binomially distributed with a mean, with n of 100, mean of success of 0.3, find the probability between 33 less than X less than 37. So in this case, you know n is 100. You know p is 0.3. You can get q as 0. Then you can get the mean as 0.3 times 100, which is 30. So because these are just less than, you see X is greater than 33. So it means probability, is this lady who has been asking me. This will be 33.5 minus 30 divided by the mean, which means standard deviation, which is sigma is root of 30 times 0.7, which is root of 21. So over root of 21 is less than Z, less than 37.5, which is 36.5. When you subtract off 0.5 minus 30 divided by root of 21. In this case, I've summarized it. Why? I never wanted to split for you to show you that probability of X is greater than 33. Then it is the same as probability of X greater or equal to 34. To get back, you subtract. Someone has already showed you in the previous example. She commented and said, what if teacher, me straight away see it's greater than, and to make it continuous, I have to add on 0.5. It is what I've done. Then this lower one is upper one, probability of X is less than 37. It's the same as probability of 36, X less than or equal to 36, which 36, to make it continuous, you add on 0.5. Then someone says, how about if for me just subtract off 0.5? You are also fine. That's why I came up with these values. Someone give me the limit.
The 0.764.
0.7064.
0.764. 0.764.
764.
Yes, 764. Then the other one is 1.418.
They are both positives, eh?
Yes.
Now, okay, someone get me the answer. There is a question I expect on this part, but no one has given it, has put it across. I don't know why.
You have 0.14433.
0.14433. 1443 recurring. Correct. 0.144. 3. You said 3.
33, Carl.
Okay.
Yes, 33.
Now, the question may be, how would you know if the question is set like that it's normal approximation to binomial? Who can answer me? How would you know that, okay, because even the binomial distribution probabilities, if you remember, they're written sometimes like that. But now, if they're written like that, how would you know it's normal approximation to binomial? Hmm? Who can guess? Yes, Elizabeth Magana.
I think you see from the number of trials.
Very good. You see from the number of trials. And what is the minimum?
20.
Exactly. So if it's greater than 20, it's a normal approximation to binomial. Guys, have you heard that statement? Some of you might have missed the lesson for binomial distribution. So for them, for the binomial distribution, we don't exceed 20. But now if you get n, the number of trials when they are greater than 20, then it is normal approximation to binomial. So that's how you know. Okay? Okay. Another example. Many minutes. In economics sometimes comes and takes us through very fast here. We have maize seeds. Maize seeds.
Excuse me, sir.
Yes, please.
Yeah, if I beg your pardon, how you got that answer?
Ah, which answer? This one. For you, what do you use? Guys, you ask a question, you disappear. Where has it gone?
Yeah, that's what I'm asking is that what did you use to get that answer?
0.1443.
Yes.
A calculator. For you, what are you using?
I was using a calculator, but I'm not well conversant with the use of a calculator.
But then why don't you ask you, man? You hear people here asking questions and for you don't want to ask. Okay, which calculator do you have?
FX991.
Okay. Press mode.
Shall continue.
SD.
Yes.
Shift 3. Let us use Q to read like the table. Put in, okay. Substitute in 1.418.
It's 0.4219.
Go back to the same thing, put in substitute 0.7641.
$0.2776.
77?
6.
Subtract, what answer do you get?
Okay, I get now, teacher.
If you want to use P, you use P. P will start from negative infinity up to where you are. Then also again, up to where you are, the big one minus the smaller one, okay?
Thank you, teacher.
Anytime. So guys, we have maize here, okay? Maize seeds have a chance of 0.45 to germinate. Find the chance of not less than 3 seeds germinating if 15 seeds are planted. So we want seeds to germinate. So success is 0.45. Those not to germinate are going to be 0.55. How many seeds are we given? 15. They want us to find the probability that, find the chance. Okay. Find the chance of not less than 3 seeds germinating. It means the seeds that are expected to germinate are going to be 3 and beyond. Not less than 3 seeds germinating means 3 and beyond seeds have germinated. So what will I have? We shall have, we can now find the standard deviation as well. Sigma is going to be given by what? Any PQ under the root, which is root of 15 times 0.55 times 0.45. What is sigma? So this will give us probability of Z is greater than 2.5 minus the mean mu. Did we get the mean? Mu is equal to 0.45 times 15. What answer do you get? $1.9262 is what?
6.75 is the mean.
6.75 is the mean. Then this one is 1.9.
1.9268.
The
Yes.
probability of Z is greater than 2.5 minus 6.75 divided by 1.9268. What answer do we get?
Excuse me, sir.
Yes, please.
Excuse me, sir.
Yes, please.
So why did you say x is greater or equal to 3 when they said not less than 3? That means more than 3 seeds.
Find the chance. Okay, Antin. Okay, very good. Probability of x is greater than 3. Is that what you want?
Yes, sir.
Wait. The question says, find the chance that not less than 3 seeds germinating. If they are not less than 3 seeds germinating, which seeds are? We have 1 seed, we have 2 seeds. 1 and 2 is impossible for them not to be germinating. So if we are looking at a point whereby we have more than 3 and above seeds germinating, I mean, not doing what? We have more than 3 and more seeds germinating, because the statement is saying the chance of not less than 3. Not less than 3 means it is impossible to have only 2 seeds germinating, only 1 seed germinating. So the possibility is 3 and above seeds can germinate. That's why I'm saying probability of X is greater than or equal to 3. If they had said not less than 4 seeds germinating, then I would have started from 4, which 4 is greater than 3, as you wish. Or if they had said more than 3 seeds are germinating, then okay. Someone with an answer there?
.98631. That's the answer.
Yeah, final answer.
The answer. Yes. The curve.
So that is ideally coming from a negative, negative 2.206. Okay. The second question. Given that this 80 seeds are now sown, here the question, N has changed. Now we have how many seeds? 80. Find the chance that less than 30 seeds will germinate. Germination is 0.45. Not germinating is 0.55. Mu will be 80 times 0.45, which answer will give us 4.5 times 8, that is 18. Sigma will be equal to root of 18 times 0.55. You can get sigma. So probability of X is less than what? 30. Remember, when you standardize, this is the same as probability of X less or equal to 29.5. So probability of Z is less than 29.5 minus 18 divided by, no, is this 18 or 36? This is 36.
36.
Yeah. You know, when the deviation is very big, just know you're going to get a value beyond 3. So you check your answer very fast. Then this standard deviation is what?
.4497. 4497. 4.4497.
Someone standardize this, give us the value. It's a negative.
Teacher, I'm just. Which part are we answering? Which part?
We're answering this one.
Yeah.
Yeah, we're answering that one.
Negative 1.4608.
Negative. Less than it is this way. Tugume Jasper, use P and give us the answer. You substitute the value as it is, negative 1.4608. Okay, 0 point. You have used the 2. I wanted you to use P. 2 requires subtracting off from 0.5. Because 2 is reading from here up to where you read. So that is the 0.427. Okay, 4278. So 42796.
0.0721.
0.0721. Thank you. Correct. Then the last part, it says at least 40, but not more than 45. If it is at least 40, but not more than 45, it means probability of 40 is less or equal to X, but not more than 45. It's less or equal to 45. So this will give me probability. When you are putting in the continuity correction, it will become 39.5 less or equal to X, less than X. We shall have less than what? 45.5. So standardized to Z, you'll have 39.5 minus the mean, which is 36 out of sigma, which is 4.4497, is less than Z, is less than 45 minus 36 out of 4.4497, close brackets. Learners can continue. With that, we have marked the end of normal approximation to binomial. There is one last number, which I had sent. I'm going to send some other few 2 numbers here. Then those of you who can do some reading, investigate and read about estimation or estimators or confidence interval, because that is our last area. And for it, we might only even need only 1 lesson and we finalize. So I'm happy to announce that we are coming to the end of statistics and probability. So the rest of what is going to come, have you received your results already? Because teacher told me was done. The one we are marking with, because I marked some sections, the other one was also marking another one. So if we are done, we are going to have another paper, which is going to be fully statistics and probability. Okay. So we should prepare by the end of October, first week of November, that's when we should expect to sit the paper. Only statistics. I will not include mechanics this time because I would like to check how my students are doing or faring in this area of statistics. So the answer there, I expect the answer to be 0.192. Then the other next number, there are other numbers I want to send you here, like this one. Let me send it right away. Then the rest you'll visit understanding, mastering what? Mastering A-level mathematics by Rama Hamza and Walgada for probability and statistics. Those of us, I sent you some of them last time, but I think some people are not yet very conversant with the topic. I guess now you're perfectly able to attempt all and go through all those examples. There are very many examples there. They're around 10 with solutions, so you better check them out. Then also there are good exercises there. We shall also take a look. Those who want the books, you let me know. We can arrange and deliver the books. Those who have asked, they have got the books. Okay, if no further questions, can I stop here and we meet next time? Have a nice day, and please keep solving always and forever. We solve until we sit the paper. If a day goes by when you've not solved, the only day you can suspend, maybe on Christmas and the Eid. But all these other days, in New Year, what? All those days, you never go to bed minus solving a number, minus trying out something in your field of science or field of study. So please, every day you need to work hard to ensure that you can all be there. With this rate and pace, if you all be consistent, trust me, you'll score the A's. Only students who have not been in this category can miss the A's easily. But you who are in this category of learning, when you go back to the real classroom life again, trust me, you will have something exceptional and you will deliver to your expectation. Okay, with that, I can call it a day and have a good day. We meet.
Thank you, teacher.
Hey, then the other thing, guys, you have to conclude on which day I should meet you. Someone was saying 9 to 10, over today night, I don't know. But people should agree so that I come and we discuss those numbers that I sent for elasticity. Agree on the group and get back to me.